Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Fayeza Ahmed, who is an assistant professor of psychology at the University of Maine. I first heard Fayeza talk about her work at the 2022 Maine Science Festival 5-Minute Genius event, and knew that I wanted to learn more. Not only is Fayeza's science path more winding than most, her work in clinical neuropsychology has expanded my own understanding of what exactly it means to be doing psychology. I learned so much more about psychology in general and Fayeza's work in particular from this conversation. I hope you enjoy it as much as I did. So Fayeza, welcome to the Maine Science Podcast. I am delighted to have you here. You were a 2022 5-Minute Genius speaker, and I remember being totally over the moon by your approach to your talk, but also learned a lot. And listeners to this podcast will know that probably my weakest point of engaging with scientists and researchers is in social sciences and the parts of science that I just don't have a lot of experience in. So I'm over the moon that you're joining us so that we can dive into that.
Well, thank you for having me. I've been really looking forward to doing this. And if I remember correctly, I'm the only one that didn't keep it within 5 minutes, both the talk and the Q&A.
It sounds to me like you're a little scarred by that. So we are going to have to alleviate that somehow. Before we dive into your work, which is clinical psych, right? Clinical psychology, and that's very broad. So I will let you explain your specific area in a minute. I was hoping you could kind of give us a background about what was it that made you kind of think, oh, this is totally for me. I want to do this. And then about science in general, and then psychology in particular.
Yeah. So I didn't take the route that most people thought that I would getting in. And so this morning I was thinking, and I guess you had to put like a tagline to my career. It's never too late to pivot. It's probably the right one to use. So I actually wanted to be a lawyer since I was 9 up through my junior year of college, basically. So I was in a poli-sci pre-law program until then and wanted to do international affairs and did the Model UN thing throughout high school. And I was very much, I'm not going to go the typical science or engineering route that a lot of my family members had done. So I kind of didn't have too much of an interest in science. I found it interesting, but I didn't think I wanted a career in that. Like I said, many years of wanting to be a lawyer, except for 1 year. There was 1 year, age 12, that I wanted to be an investigative journalist. And that's mainly because I was obsessed with the Lois and Clark show, Superman show, the 90s, and I had a little crush on Dean Cain, and I cut my hair like Terry Hatcher. It was a mess. But other than that, during college, as I was taking my courses, I just found myself not being as interested in political science as I thought I was going to be. And so I, took a 100 level psych class, a general psychology class for gen eds, and ended up really liking it. And I wasn't the best student in that class. I didn't show up to class. But whatever it was, I really liked the class though. And then I thought, well, maybe I'll drop poli-sci and then switch to psychology, but still be pre-law. And then in my junior year, I took a couple extra classes and really just thought, maybe this is the path for me. So it was really wonderful professors that really made a difference in my career. And that's something that I share with my undergraduate advisees. Students get so nervous about, I don't know exactly what I want to do right now. And so I use myself as an example a lot that you can change, and it's common to change tracks. I was fortunate in that I was able to take an extra semester in order to switch majors like that. And it gave me the opportunity to work in some, as an undergrad research assistant in a couple of labs. And so that gave me the experience to be able to then go straight from undergrad to a doctoral program.
So you went to Washington State, right?
I did, yes.
So I'm curious, that's a really big school.
Yeah.
What is it, 50,000, 60,000?
Yeah.
So I'm wondering if the size of the school also gave you the opportunity to have access to psychology classes that you might not otherwise had just because the department is so large, and that continued to spark your interest.
Absolutely. I was really fortunate. So I was at a smaller school, mainly because my dad was a professor there and I got free tuition. And for whatever reason, he decided to leave academia completely in the middle of college. And so I no longer got my free tuition, moved to Washington State where my dad had gotten a new position, and transferred to Washington State University. And that was one of the best things for me because we had the opportunity to get involved in as many labs as we wanted to, just because, like you said, it was bigger faculty. Unfortunately, at that time at my previous school, there was a wait list if you even wanted to join a lab. And I think that's changed since then. Absolutely. If I hadn't had those opportunities, I wouldn't have been able to go straight into grad school.
All right. So you jump into grad school after ditching law, which is fascinating to me. I get it, right? Like all of a sudden, then you find something, you're like, this is it. This is what I want to do. I know that your work, it's a really interesting combination. I'm stumbling because I think it's not intuitive how this connects with psychology. So this is going to be your opportunity to talk about that. Cardiovascular health, which is very medicine sciencey, and dementia and impacts on the brain. Like your work to me is so much more about the actual physical structure of the brain in ways that make sense when you talk about it, but as someone who doesn't have any type of experience with psychology except taking an entry-level class, it's not an obvious route to me. So is that something that you got into in grad school and have continued? And then now I'm going to stop and you have the floor.
Yeah, so I think it goes back to the never too late to pivot part. You're absolutely right. That's not the way most of us conceptualize psychology broadly. And even when we think of psychology, we tend to think of clinical work. We think of therapy, and that's one small part of psychology. So broadly, psychology means study of behavior. And so that can be a wide range of things, of course. And then within psychology, there's clinical psychology, its own subspecialty. And then people refer to non-clinical as, experimental or whatever, social psychology, sensation perception work, people who do more like along the lines of behavioral neuroscience, where they're working with mice or rats and, animal modeling. So clinical psychology is application of theory and evidence-based treatment for mental illness. And then my specialty is clinical neuropsychology. So taking that another step, neuropsychology means now study of brain behavior relationship. And that's so broad and so interdisciplinary. I've seen that term be used in other fields or even certainly in non-clinical psych fields when they're like, this is neuro and psychology. Clinical neuropsychology is a specialty within clinical psych, which not only studies brain behavior relationships, but the application and measurement of mental processes that gives us a chance to infer something about brain processes and perhaps structure and certainly function as it's applied to psychiatric or neurologic populations. So what that means is, and the easiest way to explain it is if somebody has something they think is affecting their thinking skills, and that can be anything. Memory is probably the one we think of the most, but attention, aspects of our language, aspects of our motor function. If there's a concern for that, an MRI does a great job giving you a really rich picture of the structure of the brain. Functional MRI, which is also very useful, still not as super detailed. When somebody sees a clinical neuropsychologist for an evaluation, what they're getting is measurement of various different brain behaviors, essentially, knowledge of neuroanatomy, going through medical records, to really try to piece together what might be getting in the way of somebody's thinking skills. And so the primary thing in clinical neuropsych is diagnosis often. And so this can be diagnosis of something like Alzheimer's disease. Clinical neuropsych assessment is still the best, most subtle way to diagnose and follow over time. But it can also be, somebody's had a brain injury. We know exactly what happened. Now the question is more about this person's trying to return to school, return to work. What areas might they need some extra help in? What are some realistic expectations? And I did for a year in grad school, pediatric epilepsy, where again, it was documenting this child is having multiple seizures. Is it now getting in the way of certain cognitive processes? So absolutely, I think most people aren't familiar with clinical neuropsychology unless they've had a personal relationship with it, I think is usually the most common thing. So the Alzheimer's stuff comes from the fact that neuropsych assessment is very much a part of early diagnosis. One of the things that got me into the cardiovascular literature was that most of our diagnoses, dementia is an umbrella category, and the most common type of dementia is Alzheimer's disease. The numbers range from anywhere from 60 to 80%, 70% of most Alzheimer's disease cases, dementia cases being Alzheimer's disease. But the second most common, or I would argue maybe even more common, was for us to say, this pattern looks like Alzheimer's disease. Based on medical record, history, their test performance. But there's also a lot of cardiovascular issues that may not have been, taken care of well enough, or, it's just been so many years of this to the point where it's starting to affect brain function. And that's when we also, this is why in a neuropsych assessment, people often get MRI ahead of time, just so you can take a look at the radiologist report. And there may already be some evidence of the cardiovascular affecting cerebrovascular brain blood flow function. And so one of the most common diagnoses is that this might be a mixed Alzheimer's, but also a vascular-related dementia as well. And so in terms of, practice, we often talk about, the same stuff that's good for your heart, it's good for your brain. And a lot of the things that we talk about at diagnosis is being able to finally give somebody in for what they're struggling with. So most people are not surprised. And then that helps them get set up for services. And not only that, recommendations of, okay, here are some other things to at least boost your heart health, because the last thing we want is to add strokes on top of what's going on. But over the years, there's been more research on vascular and Alzheimer's being more closely tied than we think. And so that's where my interest kind of came. So it came from a clinical place.
So I'm intrigued by the clinical neuropsychology. It sounds to my ears very much like neuroscience. And is the crux of the difference the fact that you're not just looking at the brain as its own entity, but you're also connecting it to behaviors and figuring out how to address it? Or do I have it totally off base?
No, I think it can be both, or it is. It's whenever we talk about something like memory, right? It's always an indirect measurement. We assume something about memory because we ask someone to remember some stuff, and then later we ask them if they remembered it. And so that's why I always say, everything is an assumption, but some are much harder to argue against than others. So when we're doing assessment, we're using standardized measures, meaning that they've been given to large groups of people to kind of get a sense of how most people perform. And we compare an individual's performance on those measures to others of their age group. So a good example is when we talk about things like the SAT or the GRE, and we talk about percentiles. Where is this person's performance compared to their peers, right? And there's going to be some natural changes as we get older. So really what we're saying is, are you where you should be? Or are there some areas that maybe are a little bit more concerning? And if so, what might be causing that? And so not only is the testing and the behavior and observation that you're mentioning, but as well as linking that to, okay, based on what we know about these particular diseases and the types of cognitive profiles they have, with Alzheimer's disease, that memory loss is so profound and early on. Whereas with other types of dementia, memory is not the first thing that changes. And so knowing those patterns. So I realized, I think I kind of ran off with this question, but with that, we get to something like diagnosis. And coming back to your question about neuroscience, I think really the difference is that, it's neuroscience. In this case, it's being applied in a different way. So I think the most common would also be like behavioral neurology has a lot of, overlap. The assessment is different. And also, med school versus psychology.
I don't know if this is an assumption that is a correct assumption or not, but I'm going to say it anyway. It sounds to me like you don't necessarily see individuals as patients with other people, but you're studying to help those folks. And please correct me if I'm wrong, but what does it look like for you to do your work and your research as a clinical psychologist?
Yeah, that's a great question. And another pivot question, because I thought I was going to be full-time clinical. I didn't prepare for an academic career. I sort of sounds weird, but I kind of fell into it and I love it. It turned out to be the perfect home. So you're right. I'm not seeing individuals clinically anymore, but as faculty and one of the graduate faculty for our clinical psych PhD program here at UMaine, and it's the only American Psychological Association accredited program in the state. So what that means, though, is that I get to be involved in student training. And so while I'm not directly seeing anybody, I'm supervising, not every semester, but the faculty and I, we all rotate through and supervise our students who are working at the training clinic here on campus, the Psychological Services Center. So I do get to be involved in that way, but it's not the same as the dementia evaluations I was doing, in a hospital setting. So when it comes to research, that's where I get to feel like I'm getting back to my people a little bit, where instead of us doing formal diagnoses, we're still doing very similar test batteries. And the students are still getting a lot of training that will be applicable both to if they do these measures via research or in a clinical setting. So we're still doing some, those testings and those kinds of things, but from the lab, no longer a diagnosis because we don't have all that access. And then in the clinic, I'm supervising other types of assessment that might not be neuropsych, but things like ADHD assessment or specific learning disorder. So I get a chance to put my feet in a bunch of different worlds.
Okay, so two things. How did you fall into the academic world instead of the clinician world? So hold that thought. And then I want you to tell me what your research is. Step me through what a research project for you looks like.
Sure. Okay. So typically the way that most neuropsych projects tend to go is turning into larger data sets and no longer, collecting your own data just for your one dissertation project. Now it's been what the lab is working on. So as a lab, I knew I wanted to explore aspects of health, like how well somebody's eating, how much exercise they're doing, and broadly kind of compare it to how their thinking skills are as well. And we know that there's a relationship there, but sometimes our measures aren't great at picking up that relationship. when I came to UMaine, was very interested and still am in working with individuals who are in the middle age range, which can be anywhere from 40 to 65. And the reason for that is that the Alzheimer's literature really says that by the time you see symptoms, what we talk about as a clinical presentation, the behaviors, by the time we see those, which, maybe getting lost going to familiar places, really struggling with formation of new memories, some difficulties with language, often are the first things that we see. By the time that's happening, the disease process in the brain that's been leading to that has been happening for not just a few years, but really decades. And so I don't consider Alzheimer's disease a disease of old age. There's a lot of things that happen that can increase or decrease our risk. So coming in here, I knew I wanted to study that. And so in setting up a lab, for me, it was not what I guess most people think, like a chemistry lab or a bio lab, but it's, do we have quiet space to test participants where we can give these measures and it's a private, quiet space so that doesn't get outed? Do we have a space where are we going to store sensitive information, and how are we going to de-identify the human participants, and just, data storage, meeting space. So that's really how a lab gets set up. For the study, after really trying to carefully design as much as we can, the primary factors that we might want to adjust for. So for example, I would want to make sure that if I was looking at something like memory scores and the level of physical activity that somebody engages in, if I'm trying to compare people that have widely different years of education, that does impact how people might perform on a measure. And you could have like a whole podcast series, how things like education can impact certain areas of cognitive performance. So anyway, once we've designed that study, the next step is to submit the proposal to the Institutional Review Board to make sure that everything is happening ethically. After that, the big part in our research is really recruitment, getting human participants. So that's probably one of the slowest parts of the project that, depending on what you're studying, you may not have that as an issue. So finding individuals in the community who would be willing to participate in these studies. People come into the lab, on them, they get compensated. And then we start scoring all the data and start trying to take a look at visualizing the data and tweaking our research question and saying, we thought we'd see a difference here on this measure. Maybe it's because the measure is not that great, or maybe it's because everyone who's in here is already cognitively healthy. Now we're looking at these subtle changes. And so I think very similar to all other types of science, it's that same trial and error, hypothesis driven, well designed, and then trial and error in terms of the details and creating a program of studies instead of one main project.
Is there a minimum number of study participants that you all have to strive for to make sure that your data is valid?
That's a great question. It really depends on what you're studying. But yeah, what you're talking about for those listening is, a power analysis. What is the minimum number or sample size I would need in order to find an effect at the small, medium, or large size? So one way to do is there's a publicly available program called G-Power that I've been using since grad school. And I think everyone has always, and they continue to, where based on the type of statistical analysis you plan to run, it will give you an estimate of if you wanted something that was at a medium effect size, here's how many more people need to be in the study at minimum. However, if you already know that there's been several studies in that area, another thing to look at is, what is the effect size of the studies that have been similar? And then that gives you a better chance of knowing, okay, what's the best sample size for my study. So for example, a colleague of mine does research that is on the visual system, and the effects of some of those phenomena are so large that they only need like 10 people, per condition, which sounds like nothing. Whereas for my dissertation, because it was human subjects and it was thinking skills and it was all these things, we had so many controls that I had to have at least, 150 or something like that. So yes, the more complex the study gets, the more variables that you want to look at, the larger the sample size. And so this is where, with a lot of amazing data sets that exist right now, people can start to really look at some big data with hundreds or thousands of participants to draw conclusions.
So I'm going to have you explain what you mean by the big data and the larger data sets and how you can use that in your work. Because I think most people like me, where you think, gosh, you have to go and find 150 and 200 people and make sure that you have enough so that the outliers and however it gets skewed. The data set part is super interesting. So if you could explain that a little bit, that would be great.
Yeah. I think any graduate student, certainly in our field, and I think in more fields, should get experience with. And I think the pandemic was a good example where we couldn't collect data, but there was these existing. I'll use dementia and Alzheimer's as an example. There are various programs, NIH, National Institute of Health funded, for example, or NSF funded, or privately funded, or a combination, where there may be multiple centers collecting data on a particular clinical population. So, for example, one is the Alzheimer's Disease Neuroimaging Initiative, which has been around for a long time. But it's several different centers where they're getting not just neuroimaging, so like MRI as well as fMRI and other sequences, but also doing neuropsych evaluations, and the individuals in ADNI donate their brain. The part of it is also donating the brain. And so because there's so many centers, there are thousands of people in that data set. And then over the years, ADNI has brought in to also include individuals who don't have Alzheimer's disease, but they have what we call mild cognitive impairment, where the cognitive changes are more than what we would expect, but it's not dementia yet. As well as ADNI has expanded to include individuals who cognitively are healthy as kind of a third group. The Framingham Heart Study has been going on for decades and decades, and the whole goal was, looking at what's causing heart disease. And with Framingham, that original cohort, their children and then their grandchildren, were each part of that study. So another example, just thousands of individuals. So sometimes, depending on the data set, you may be able to access it for free. Sometimes it's for cost. But in any of these things, there's a process of proposing a study that you would like to do with that data set, it getting approved, and then, an administrator giving you that whatever subset of data you need to complete your analysis only. And that can take time, but it's a really wonderful way of easily accessing thousands of data points that no one person could do on their own, or no one center could really do. And so that's where things have shifted, and it's an exciting part of science. The Alzheimer's Association recently at one of their conferences talking about more of these sort of global centers. There's some really amazing research out in, Scandinavian countries that have health data for everyone. And now there's a similar thing being conducted out at Wake Forest University as like the US hub. And then there's a new one, I think, forming in Japan. And again, the goal is now let's take big data globally.
Do you plan your research projects so that they could be added to these other larger data sets so someone else could incorporate parts of that in what they're looking at as well? Or is that too far afield?
That's a great question. It depends on your funding. So, for example, with NIH, all of that gets in the repository, so anyone can access that data. But if I wanted to say, hey, I want this to be added to the ADNI data set, that wouldn't, I would have to be part of that center. But what we're continuing to do more about reproducing results, finding new results, seeing if that's replicable. Other researchers might say, that's an interesting question. This is what they found at this institution. I wonder what it's like with this tweak here. In the same way, I'm designing, studies in that way. But yeah, adding on to a bigger data set, you have to already be part of that system.
Okay, and I'm going to make you go back and explain to us how you ended up in academia, because you said you fell into it, and I'm totally intrigued because that's not how most people think about academia.
So I started grad school thinking I wanted to, I joined my advisor's lab, and he used to do work with individuals with schizophrenia and the family of schizophrenia. And that's what I thought I wanted to do because I had an undergrad experience volunteering with individuals with schizophrenia, bipolar 1 disorder, and additional ones. So I joined and I thought, I'm going to just, run MRIs on them. I had no idea what I was doing. And then I got put on a pediatric project and I thought, well, no, I like this. And I thought I was going to work with kids. And then I did 1 year of graduate practicum training in a pediatric setting and realized it wasn't for me. I think for me, I found it harder. Sometimes you would see these cases that kind of stuck with you. And so my advisor also did some dementia-related research. So I started doing that and got interested. But yeah, I thought I was going to do clinical. I really liked doing the evaluations all throughout my training. And it was during postdoc that I started finding myself recognizing that I might get burned out if I don't have some additional variety, which is not good for me, but also not good for the people I'm trying to work with and help. So then I thought, let me just kind of take a look and just see if anything, sticks. I was really fortunate to get a position at a small college that really helped establish my love of academia. And really, that's how it helped me get to Maine. But yeah, it was sort of on a whim. I knew I liked teaching. I always liked teaching and training. And I thought, well, let me try this as well as applying to clinical jobs. And the draw was more desirable for me.
I think I would argue that is not so much a whim as having the good fortune of figuring out that maybe clinical work for 40 years is not something that was sustainable for you. Like you said, the burnout and that is not trivial. I have a twin sister who has a degree in psychology, and at one point she was doing work and I as a volunteer counseling rape victims right at the hospital. And I thought I could never do that, right? And so it was always really interesting. We're super different.
Yeah. And I agree. Grad school friends of mine who specialized in trauma, I knew that was an area that would burn me out. And that's an area that sustains them. But then they'll tell me on the flip side, I don't think I could give diagnoses to individuals and tell them they have Alzheimer's disease. How do you do that? And not, so I think it's, you find in your area, what really drives you and where the like special moments are. And I think with the diagnosis part, while it's certainly not happy news, in my experience, the majority of individuals that given feedback to, have a separate appointment and given the diagnosis has been a relief because they're like, okay, now we have a name and now we're eligible for services. But that can be one that somebody else may not be able to do.
So tell me a little bit more the connections with the cardiovascular health and the dementia. Like, what have you found in your work that has been surprising? Where do you think the research is going? And it seems to me the more we learn about this, the better able we are to start to really consider how to address it in ways that are meaningful. Like you said, Alzheimer's is a many decade-long process before you get there. But it also strikes me just in general, really connecting dots for people makes it more justifiable to be like, well, if you want to be better when you're 70, do this now. Like, I'm just curious what you think of this.
Yeah, I think in general, these fields are becoming more and more integrated, right, or interdisciplinary. With this work, some people can say, well, that's clearly clinical neuropsych, but others can say that's also health psychology, clinical health psychology related fields, or just in general neuroscience. I think with the research with vascular, the idea really is continuing to emphasize this mind-body connection, right? How much chronic stress can impact the system and how much something like chronic stress can add to increase in abdominal fat deposit, and how that is one of the symptoms of metabolic syndrome, which is more than just the sum of its part of being either type 2 diabetic or insulin resistant, and having the abdominal obesity, having high cholesterol. All of these things we know are bad for heart health, and we know that heart health and brain health, it's all the same. The blood has to get somewhere. And so in coming to the vascular cognitive relationship, our brain doesn't have anywhere to store oxygen. So it always needs that steady supply of blood to get, glucose and oxygen to the cells that it needs. So whenever there's disruption in that system, right, we're limiting those nutrients to our brain. And this also includes things like sleep apnea. Those are periods of time where people are either not breathing or they're getting lower oxygen. Over time can have an effect on brain function, so not getting that steady stream, but also lack of sleep makes you tired and less able to attend. So, that's a good example of how we're looking at both the effects of, well, I'm tired, it's hard to focus, as well as like biologically, I'm tired, I'm not getting oxygen to my brain, and both of those affecting our cognitive functions. So with Alzheimer's disease, some of the early changes that we're seeing are very much related to our blood supply system. There's been several genes that people study. One of the ones that has gotten a lot of attention, even commercially, people are trying to test for it, is related to cholesterol transport. And we know that early on, before people even show any symptoms, this paper came out in 2020 in Nature, that our blood-brain barrier, that it starts to become more permeable in individuals who are at risk for developing Alzheimer's. So before they're even, just having that extra risk or the family history and stuff. So many will argue, well, then how is there not a vascular component? But others will say there are cases where you don't see vascular problems and Alzheimer's. Those are less frequent cases. A lot of this started with the fact that on autopsy, individuals who had Alzheimer's, so many of them also had this vascular pathology that in their brain, these areas, that we'll call highways that connect things have a lot of roadblocks. Right. And that's just evidence that high blood pressure, high cholesterol, whatever's happening at the level of the heart has gotten to the way where it's affecting blood flow in the brain as well. And so, as you were saying with research, right, the more and more we learn about this, we're in an unfortunate place where drug trials aren't that successful. And so more and more has been about how do we at least prevent or delay onset. And so more and more people understand this concept of modifiable risk factors. I can't change that each year I'm getting older. I can't change my genetics, but I can be a little more proactive. In terms of findings, we just got a paper accepted that I'm really excited about where we looked at light activity. We're recommended, World Health Organization, all organizations say 150 minutes of moderate intensity activity a week or 75 minutes of vigorous. And then that sounds daunting, but several years ago, they said it doesn't have to be 30 minutes at a time. It can be in 10-minute spurts. And then more recently, newer papers came out where they changed it and they said 10 minutes is sort of an arbitrary cutoff. Just do anything is better than nothing, which in terms of motivating people is great. But when we think moderate, we think, oh, okay, you've never exercised before. That's hard. So using a data set, the Maine Syracuse longitudinal study, a 40-year study, we were able to look at participants who, just based on walking speed, we looked at kind of light, low levels of walking speed, and then the moderate and vigorous ones. And the literature is mixed on how beneficial low levels of activity can be. However, there's some promise that, maybe levels of activity can still have some benefit. And what we were able to find in this study, and because it was a data set, there was over 900 individuals examined, we found that just even the slightest change in walking pace, which to us, both paces probably look really slow, but technically one is a little bit more light. Going from light to moderate is surprisingly easy. But even at the lower levels, going from very light walking to even just going up to like a casual pace had a little bit of benefit for individuals over around a 6-year period. So I'm excited about that because one, it's adding to the literature. And two, from what we call from a behavioral medicine standpoint, when you're working with a client and you're trying to motivate for change and somebody's never been physically active before, or they're, it's daunting to them, it's nice to be able to say, here, well, there's data that says that even doing the teeniest amount might have a little bit of benefit. And you're more likely to be able to stick to a lifestyle change when it's small and gradual. So I'm excited about it, both from a mechanism perspective, but also in a public impact perspective.
Your field of work, it seems so like what people used to talk about with rockets in the 50s and 60s, right? There is so much we don't know. There's so many different ways to learn things. And no one else gets to see this but me, your smiling face talking about how exciting this is. It seems to me that there are so many different things that you can look at that will have impact on people's lives that it's got to be super invigorating to be doing this every day.
Yeah, I have those corny, this is why I went to school for this, but it feels so great. And I think that's what motivates us all.
Plus, you get to learn all this really cool stuff. I'm always psyched about that.
I think, I often teach a senior seminar on Alzheimer's disease, and most of the students, these are seniors in psychology, kind of think, well, we talk about in all of our other classes, the complexities of depression and all the different things, and different anxiety disorders. And people are like, we feel like Alzheimer's should be straightforward. And it's so surprising that something that seems more straightforward is still so complex.
All right, last question, and you don't have to answer it.
Okay.
Have you found that your research about the vast impacts of cardiovascular health and sleeping and things like that, and the impact on the brain, how much has that affected you at a personal level and what you do?
It should have made me even more active in my life. And even,
This is why I said you didn't have to answer. Just saying.
Sometimes I wonder if I just say, do as I say, not as I do. Yes, we all splurge every once in a while, but being aware of the aspects of, taking it back, I think the thing that's impacted me the most is recognizing how much more active I am than I think I am, or even just switching from took the stairs this day and I couldn't take it the next day. That's okay, because it's small incremental changes that'll help. Or, with diet, certainly some foods that I don't think I can ever look at again. But again, also recognizing, in moderation, here are the things that we can eat, Mediterranean diet. It's had an impact for sure. I have yet to meet someone who's either taking a class related to Alzheimer's disease or working in the field who hasn't had some sort of personal connection to it, either a family history or whatever. So I find it fascinating from both science as well as learning about ourselves and saying, this explains why grandfather did this, or yeah.
Well, Fayeza, this has been a really great conversation. I have loved learning that your path to science was so winding. And even once you got into it, equally winding in a different way, a lot of switchbacks. This has been really great. We didn't even touch on half of the stuff that you introduced at the 5-Minute Genius Talk. So I'm going to put a link to that in the show notes so people can see that. But I really appreciate this. I appreciate your time. Summer can be a hard time to get faculty. I know it's a really precious time for you for all sorts of reasons. So I deeply appreciate your time on this. I appreciate your work. I think it's really cool stuff and really important. Maine being the oldest state in the country, which I'm sure most people throw at you when they talk to you about your work. I think it provides a really great opportunity to the incremental stuff that you talked about is really inspiring to hear about because it does seem overwhelming sometimes to change everything. So anyway, I appreciate all of this. Has been really great. Thank you.
No, thank you for having me. And I have to say that Maine, but also University of Maine, everyone has been so supportive and of this type of research that it's been really easy to delve in. And with engaging with community members, everybody has an interest and a dedication towards brain health and preventing things like Alzheimer's. So I'm in a good place here.
Excellent. Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. The Discover Maine theme was composed and performed by Nick Parker.